We were talking about even and odd functions. So I was telling you an even function, when you plug in a certain x value, and it's negative, so if I plug in like 2 and also negative 2, then I get the same y values out. So an even function is like y equals x squared. That's our most basic even function, okay? An odd function is when you plug in like 2 and negative 2, and you don't get the same thing, but instead you get opposite numbers. So maybe you get 8 and negative 8, right? That would be an odd function. So something like this. That's symmetric around the origin. So do you guys remember how I did the little spinny thing? Yeah. So that's flipping it around. And I didn't know that when I was in high school. I was like, what is symmetric around the origin? What does that even mean? It means 180-degree rotation. Okay? And then neither, we could have parabolas off to the side or so on that aren't symmetric around the y-axis. Okay? So we're going to do the test to see if it is even, odd, or neither, and then also if it's continuous. Okay, so a continuous function, basically I can plug in every single x value. So its domain is going to include every single x value. So on this one, on number 1, what's messing up the domain? X squared, right, on the bottom. And what is x not allowed to be?
0.
0, right? So x cannot be 0. Okay, but can I plug in things on the right side and the left side of 0? So could I plug in like 0.1, negative 0.1? Sure, right? That's allowed. But what's happening at 0, and if you sketch this out, it looks like this. So if you use your calculator and you graph 1 over x squared, you will get that shape. Would I be able to draw that without lifting a pencil? No, I would not. So this is not continuous. So not continuous. And it's because its domain is negative infinity to 0, but we have to skip over 0, so then 0 to infinity. Okay, is it even, odd, or neither, though? Is it symmetric with respect to the y-axis? Yeah. So when I tutor students, I often tell them there's a way to do this mathematically, right, to test if something's even, odd, or neither, and I'll show you that. But there's also a quick way of doing it in your head, and that's to use the number 2. So if I plug in 2, what do I get when I plug in 2? 1 over 4. What happens when I plug in negative 2? I also get 1 over 4. So since I get the same value, that means it's symmetric across the origin, or across the y-axis. So you could plug in any number. If I plug in 5, 1 over 25, I also get 1 over 25 when I plug in negative 5? Yes, I do. So the way that we write this out using, math terms is we do f of x is 1 over x squared, and we do f of negative x. Well, when I plug in f of negative x, I get 1 over negative x squared. What does that become? Should have given more room for these. It becomes 1 over, what's a negative x squared? The negative squared becomes positive, right? And then x squared. So it becomes 1 over x squared. Is that the same as f of x? Yeah, it is. So this is what we would call even then. So if you get the same thing out, it's even. If I get an opposite, if I had negative 1 over x squared then, like a negative out front and 1 over x squared, that would be odd. Okay, but again, just think about the numbers you're plugging in. So this is an even function. All right, so the next one. So I have g of x equals the square root of x plus 5. Okay, so something is definitely affecting its domain. What can I not have in this domain? I can't have the square root of a negative, so what's the first number that I can't say first number. What's the last number I can have? Negative 5. Can I do negative 5.1? No. Negative 6? No. So this domain, sometimes it helps if we think about the domain, starts at negative 5 and it goes to infinity. Okay, so when I just talked about continuous, maybe I didn't phrase it very well. So we want to think about its domain, and we want to say, is there a place in the domain where I would have to lift my pencil? There's not, is there? So if I was sketching this out, and you can graph it on your graphing calculator if you want. So if I graph the square root of x plus 5, square root is second and then the x squared button, and then I have x plus 5. It looks like part of a parabola. It's going to be a parabola that's kind of like on its side, but there's only part of it. There's only half of it. So this function started over at negative 5, and it went like that. Okay, can I draw that without lifting a pencil? Totally, right? So is it continuous then? Yeah. continuous on that domain, so it is continuous. Okay, is it even, odd, or neither? Yeah, do you have a question, Kinsey? Yeah.
So, if you see an example in the domain is like 4, negative infinity, so that is continuous, even though it's not like infinity.
So like negative infinity to 4, yeah, that would be continuous. Okay. Yeah. As long as you don't have like the union part where you have to skip over a number, you're good. I think that's the best way to say it. Okay, so all right, is it even, odd, or neither? So is it symmetric across the y-axis? So can I fold it over and get the same thing? No. Can I rotate it and get the same thing? No. So is it either of those? No. So this is a neither. So if I was trying to prove that and like write it out with math, I would do g of negative x, and I'd get negative x plus 5. Okay, that's not the same as either of those that we had. It's not the same as like g of x or negative g of x. Okay, so this next one. So we want to decide if it's continuous. So what about its domain? So what can we not have in the domain? 0 for the denominator, right? So let's set x squared minus 9 equal to 0. So what's bad? 3 and also negative 3, right? Okay, let's see what happens on this picture. So I have negative 1. This was a section that you guys had last year. You guys hated it. It was section 9.3, graphing rational functions. It had like slant asymptotes, horizontal, vertical asymptotes. You guys remember that? Okay, my calculator is giving me something really weird. Okay, and you really have to understand what this graph looks like to interpret what's happening with the calculator. And you could try to zoom in and figure it out. Okay, what do we think is happening at 3 and negative 3? Not holes. Holes are where you cancel out on the top and the bottom, the same thing. Okay, these are asymptotes. These are vertical asymptotes. Okay, so right here on this graph, we're going to have little dotted lines that it's not crossing. So sometimes your calculator kind of draws those in too, which can be very confusing. Oh man, I was trying to draw on top. It's not letting me. Darn. Here, let me try something. Yeah, it's fine. Okay, so basically I have these vertical asymptotes at 3 and negative 3 that I'm not crossing. All right, there's also a horizontal asymptote. The horizontal asymptote ends up being at 0. Okay, and then we want to know what's happening on each side. So you could plug in points. You could always go to table, and you could find some points. You'd say, oh, at 1, I'm at 0.125. At 2, I'm at 0.2, and so on. I'm above the axis. It ends up being here. And then these ones end up being down here. Okay, but we're not really worried too much about what the graph is looking like. What were the questions I was trying to answer? Is it continuous? Can you draw it without lifting your pencil? No, because of the 3 and negative 3, right? So it's not continuous. Okay, is it even, odd, or neither? What do you guys think? It's even. And think about plugging in again 2 and negative 2. Would I get the same output? If I plug in 2 and negative 2, I have that x squared. That's all that's affecting it, right? And x squared is going to be the same for both of them. So it's even. All right. So the last thing we have to talk about are piecewise functions. So we did these in Algebra 2. You didn't like these at first either, but I think you guys figured them out. So let's see if we remember them. So a piecewise function is specified by 2 or more equations over a specified domain. I don't know why I used specified twice in that definition. All right, so sketch the piecewise function. All right, so on the right-hand side, it's telling us the different domains. So the way I had you guys do this in Algebra 2, if you were in my class, is I had you write the 3 different parts. So the first one is that y is equal to negative 2x minus 10. And that's for x values that are smaller than negative 5. So I went ahead and put negative 5 in the t-table, but I always write open next to it. I know that that one is an open point. Because I could plug in like negative 5.1, negative 5.01. I could get as close to negative 5 as possible, but I'm not going to touch negative 5. Okay, but I could also have like negative 6, negative 7, and so on. So when I have negative 5, I get negative 2 times negative 5 is 10. Minus 10 is 0. The next one is 12 minus 10, which is 2. And the last one is 14 minus 10, which is 4. Do you guys see those? So I have negative 5, 0, 1, 2, 3, 4, 5. And that's an open circle. I have negative 6, comma 2. And I have negative 7, comma 4. And it's going to continue that pattern. It's just a line. So one thing that people made mistakes on last year is they often just drew these as open because they were like, oh, the first one was open. These are all open. They're not open. The only one that's open is that very last one. So it's just saying we fill in that line all the way until that point, but we don't include that point. Does that make sense? Yeah.
Is the line dotted because
it's not dotted?
Okay.
Nope. All right, so then we do y equals 7 is the next one. And that's between negative 5 and 1. So we could plug in negative 5, negative 4, and so on, all the way to 1. But let's think about the endpoints. Which ones? One of them's filled in and one of them's open. Which one's filled in and which one's open? Yeah, so we're going to say closed. And then 1, we don't include it. It's not in the domain, right? Because it says x goes all the way up until 1, but it doesn't include 1. So that one's going to be open. And my function is just 7. This is what we call a constant function. It's just going to be a horizontal line. So I'm going to have negative 5, comma 7, 1, 2, 3, 4, 5, 6, 7. And that's a filled in one. And then filled in, filled in, filled in. These are all 7 until we get to 1 where it's going to be open. So we're going to have a nice horizontal line there. We like those ones. Those are the easy ones. All right, and then our last function that we have is y equals x squared minus 8. And this is for values bigger than 1, greater than or equal to 1, right? So it's going to be closed. So we're going to have 2, 3, and so on. Okay, so knowing the shape kind of helps. It's an upwards parabola. Part of it. It's just going to be a portion of it because we're not including the whole domain. So when I plug in 1, I get negative 7. When I plug in 2, I get negative 4. When I plug in 3, I get 1. So 1, negative 7, 1, 2, 3, 4, 5, 6, 7, and it's closed. 2, negative 4, 3, comma 1. Okay, and just kind of draw a little bit curvy so it doesn't look like a line. It's like that. That's our piecewise function. On a scale of 1 to 10, or 0 to 10, how much do you remember that? Yeah, you're at an 8. That's pretty good. I'll take an 8. You've never done that. So it's blowing your mind. All right, so yeah, if you've never done that, let me know if you transferred from another school. I know, I always love when I teach consecutive classes because then I always have students that are like, we never did that. I'm like, I know exactly what page of the notes that is. like, you did.
I remember seeing it. But
it was at the beginning of the year. All right, so evaluate the following. So if I'm finding f of 0, f of negative 2, f of 5, really I'm worried about where it is in this domain. Okay, so where is 0 in this domain? Is it smaller than negative 5? No. Is it between negative 5 and 1? Yeah. So if I'm finding f of 0, I'm using the middle part of the function. So that was the one that was y equals 7. So if I plug in negative 5, or not negative 5, 0, I get 7. So then I say, well, where's negative 2? So I go up here and I'm like, okay, negative 2. Negative 2 is between what? It's which one? The top, the middle, or the bottom? It's in the middle. It's between negative 5 and 1. So it is also 7. What about 5? Top, middle, or bottom? It's on the bottom because 5 is greater than or equal to 1. So I plug in 5 and I get 5 squared is 25 minus 8 is 17. 15. 15 squared, you guys know 15 squared? 225 minus 8, 217. And then negative 100, which one, top, middle, or bottom? top one. So negative 100, I get negative 2 times negative 100 is 200 minus 10, so 190. All right. Feel somewhat good with that? Do you guys want to try another piecewise function? No? You're good. All right, I'll practice with you if you haven't seen it before. All right, so we're going to stop there.